Hi, Phil here from Trafford College Group, Stockport campus, where I teach on the HNC Building Service Engineering. One of the things we look at, and is usually the most complex and perhaps confusing part of the course, is looking at index runs on piped and ducted systems. Now, quite typically, the index run is the important part. It's the bit that tells us what the highest point of friction down the system will be, and that we need to overcome that point of friction. So we can do that with calculations beforehand, but to be honest, to most of you that does not mean a great deal. So we're going to look at this in sort of a practical demonstration and see that there's a point on a pipe system where the friction is highest, and that is where the water will run out the slowest, or the lowest amount of pressure. There's another point which will be the highest amount of pressure and flow, and that's the easiest run. That's where the water will be running straight through, and quite typically we would use those 2 points to control the flow throughout the entire system. I say we, of course I mean the commissioning engineers that would be responsible for setting it all through the use of control valves. So next we'll be looking at the test rig that I have set up ready to look at. So here is the test rig, which has a water inlet, 6 valved outlets, and obviously different convoluted lengths of pipe getting to each outlet. We'll use this to see which one is the index run. Got water running through the system now, and we can see that the water is running clearly through some of the outlets, not so much through the others. Let's have a quick look around them. That one's running around about 1 centimetre high, that one a little bit more than that one's around about 1 centimetre, that one's fairly low, that's perhaps the highest, and this one here is barely trickling out. So we can see, because of the amount of flow that's coming out of that outlet, which is the least, shows that the most resistance is actually up this run, so from there to there. The highest run is either to this outlet here, or possibly to this outlet here, where we can see that the water coming out is coming slightly higher, about 15 millimeters. So what we want to do is to then decide that is the index run. That is where we would have to calculate the resistance to overcome. We would put a pump in, or a circulator, or a pressurization system to make that run to the level we wanted it to run to. So we'd do that by cranking up the water coming out of the tap in this case. So we've reset the flow coming out of the tap. We can see now that there's no difference at all, hardly any difference, in the water coming out of our index valve, which indicates it's not down to the amount of flow, but the amount of pressure that's holding that one back. So we'll then hand that information over to the commissioning engineers, and they would then look at how to control that. Start off by looking at the outlet with the highest flow, which appears to be this one. Crank that down to around about 1 centimetre above the outlet where we want it. We can see then there is a slight increase in the amount of flow coming out of that tap. So let's come to the next one. Let's turn this one down a bit. Get that to about 1 centimetre. And this one down to about 1 centimetre. And we can see now that we're actually getting more flow again through that one. Still not quite what we want. So instead let's turn this one down a bit, and as we get this one down to the right level, we can see that this is having a detrimental effect on this one, although this one is now running virtually where we want it. This one flows up a little bit, so let's turn this one down a little bit, down to about a centimetre. This one now is running absolutely fine. So let's come back to this one again. We need to get this one running right, and we can see that it's difficult making this one run correct. We've either got a thin squirt coming through, which is not much good, whilst everything else is about right, or it comes out with more force there. Let's just open this one up again a little bit and get that flow right, see what effect it has on the others, and we can see. So it is a lot of juggling to actually set a system up, but by making sure it's right, we get the system in balance. But we can see clearly that this is the index rung, this first outlet here, and if we were providing sufficient pressure to meet this one, then there would be more than enough pressure to meet everything else. This one with its funny squirt will probably mean it would need a pressure reducing valve perhaps to actually get that down to the right flow without it squirting. So we've seen now that the water through the system has run to an unexpected point, probably the closest outlet to the inlet of the system, which means that the rest of the system is running at a lower frictional resistance. So regardless of what you where you think it might go, that's where it's going. So we do need to do all the calculations. We can't, I'm afraid, look at a schematic diagram and say it must be there because it's the longest, or it must be there because it's the most complex. The dynamics involved through the system do take into account slightly kinked bends, slightly rough joints, bits of solder, burrs on the inside of the pipe will account for that. And so we do need to we can't just take it at face value, we do need to work out the frictional resistance in each length of pipe, and work out each of those sections together to find out what the index run should be. That then is information given to the commissioning engineers who would set the valves accordingly, and the better our calculations, the less time and obviously money will be spent by the commissioning engineers setting all of that up. So I hope that's been a useful demonstration. It does show the practicalities of why we have to do the index run calculation. So more details obviously in class where we're picking up the calculations of what we're doing.